Let's try to derive the torque that the motor needs to supply. Torque will equal to the time derivative of angular momentum. So we just need to figure out the angular momentum and then differentiate it, then we get a torque. The angular momentum will be the moment of inertia times the angular velocity. The key is that the moment of inertia will be that of the winch plus that of the cable, and the moment of inertia contributed by the cable will be the mass of cable surrounding this winch times the radius square of the winch, and the mass will be the length over here times the linear mass density. And as the time goes, the length on this winch will increase. Let's say at t equals 0, there's no cable on the winch, so it can be replaced by Vt, which V is the velocity of this moving cable. And we can replace it by r omega, so we get r omega lambda t. So the angular momentum will be a constant moment of inertia plus a omega lambda r cubed, because here we have r and here's r squared. M times r squared gives you r cubed, and we have a time here. The whole thing multiplying with angular velocity. So the time derivative will give you a time derivative here. So the answer will be lambda omega squared r cubed. So here's how we get the torque. It will be proportional to the mass density of the cable, and the faster you rotate, the bigger the winch is, the bigger the torque.